This video will do a brief walkthrough of solutions to assignment 1. So I have RStudio open here. Let me go ahead and start a new project where we can store our code. So I'm going to go to Create Project. I'm going to put it in a new directory. I'm actually going to browse to my desktop and create a 267 folder there. And then within that folder, I'm going to have a directory that calls this assignment 1. Okay, so we'll go ahead and create the project. So it's going to go ahead and set up. Notice it's moved me into my desktop, into the 267 folder, into the assignment 1 folder. That's my project file where it stores the attributes of the project. So I'm going to cheat now. I actually have a solution file. So let me go ahead and bring that into my session by just open a folder and double click. Let me expand this window so I can see this. Now the first thing is, notice that I opened this, I did not have this script file in my project folder. So the first thing I should do is actually do a save as, and I'm going to save this into, notice that it defaults to my project to the area where I have the project folder. So I want to go into assignment 1, and I'm going to save this script here so that it's actually part of my project now. I'm not going to do any subfolders. We don't need that level of complexity, I think, for what we're doing here. So let's go ahead and look at, now we have a project set up, so let's go ahead and look at question 1. So in question 1 we were considering this data set here that we had created and asking you to create first the vectors associated with the columns in this data frame. And to do that, let's just quickly walk through. So the first thing, to create the ID variable, you can use, you could use a column vector command like we've done here for age, but you can also just use 1:5. And what that'll do, I'm going to run both these lines of text. So let's look at the first line of text. Notice that my console is over here. If I can get this to pull down a little bit so I can see a little more. Here's my console. My script window is configured to be on the left. So if I run this first line of code that I've written here, or actually Megan's written, it's not going to give me any output. So I have to actually type the name of the object with nothing else, and that will just create the integers 1 to 5. For gender, we can use create a simple vector using C notation, and let's go ahead and run that. Notice that we have double quotes around each element within that vector to indicate that it's a character entry or element. For age, we obviously don't need quotes. We can just put the ages directly in, create a vector, and the same for FVC. Create those and get it to just print out the results so we can see. So now, now that we have these individual things, I want to point out one thing is down here I've got this window down here, the Workspace minimized, but if I click the button that brings this up a little bit, notice that in my Workspace now I have these 4 separate objects. I have the age, which is a numeric vector of length 5, FVC, same, ID is an integer. Notice that the way we created that results in an integer type, but again it's just a numeric. And then gender, we have a 5-element vector that is a character vector. Okay, so let's go ahead and minimize that window again. We don't need the Workspace right now. I can just go back and forth clicking these. This button here will bring it halfway up, and then this will maximize, this will minimize. So now that we've got these individual vectors in our Workspace, we can create a data frame, which is the right thing we want to do. Use a data frame to create our data set. So we're going to call this data 1. We have the assignment symbol, and then we're simply going to type DataFrame, and then we're going to list each of our vectors in parentheses separated by commas, and of course just printing the data one will print out the result in the console so we can see it. So now we have a data frame with ID, gender, age, and FEC. Now just to see what can go wrong, let's store the data as a matrix, because that was the other option. And so if we say data1 evil twin and type that in, what will happen? Notice that by creating a matrix, we've coerced everything to be character here. So ID, gender, age, FEC are now all character variables, which is not what we really want, right? So notice here so I brought up my workspace again. Data 1 is 5 observations of 4 variables. Data 1 evil twin is a 5 by 4 character matrix, which is not at all what we really wanted. Okay, so let's go on to part D. I'm going to bring this over just a little bit so we can see. So suppose you wanted to look at the age of the 4th patient in the data set. There's more than one way to get this element printed in the console. One would be to identify kind of the 4th row, 3rd column. So if we run that, that'll give us 75. Another way would be to identify the 4th row and then name the column. So it's the age column, and that uniquely identifies the same location. And a third way to do this is to provide the name of the data set or data frame, and then $ precedes one of the variables in this data frame, age, and the 4th element of age. Right? So this is another way that will identify exactly the same thing. Now it's important, the $ notation is important because if you want to refer to a variable that exists in a data frame, you need to reference the data frame that you're talking about. So you would reference the name of the data frame, $, and then the variable within that data frame that you want to operate on. Okay, so part E, again, there's also going to be more than one correct answer here. So sometimes it's useful to work with only a subset of the variables available in a data set. From data 1, create another data set that contains only subject ID and FEC levels. Call this data set 2. So data 2 can be created by taking column 1 and 4 from the data frame. If we run that. So if we go back up here, column 1 is ID, 2, 3, 4 is FEC. So we've referenced them by their numeric locations. Now notice also, I want to point out this notation here. The semicolon allows you to enter multiple commands on the same line. So when we put semicolon here, we're telling R that we're ending the current command and we want to start a new command. If we take out that semicolon, it'll give an error because it won't know what's going on. But this is just a compact way. You could certainly just put data 2 on the next line. This is a compact way to enter multiple commands on the same line. Another way to create this subset would be to reference instead of the column numbers, the column names. So it'll give us the exact same result. Run that. And then another way, which we talked about in 241, is to use the actual subset command. And the syntax for the subset command is the first element here, we name the data frame that we are interested in operating on. And then the select option allows us to specify the columns in that data frame that we want to operate on. And so we say select equals, we use C notation, and we just, in parentheses, list the 2 columns, the 2 variables that we're interested in within the data frame, and then we print out the data frame using semicolon. So we get the exact same thing. Okay, so let's move on to question 2, and now we're going to look at some commands and the impact they have on the different objects. We're going to operate on some of these objects. So if we look at the ID variable, let's submit the command 2 asterisk or 2 times ID and see what the output is. And we've got it right here, but I'm going to go ahead and type it in. First, let's type in ID and let's run that and see what we get. Now the important question to think about here is, why does this work? Why does this print out anything? Because we have not referenced, think about this a minute, we have not referenced our data frame. In order to reference the data frame, we would have to do this. Data1, $ID, highlight that, and run it. It gives us the same answer, but they're referring to different objects here. So let's bring up our workspace again, and notice that way back at the beginning of our session we created ID. So when I type in ID with nothing before it, I'm referencing this vector here that we created at the beginning of the session. I'm not referencing the data1 data frame. That's an important point to make. Right, so this works because we have the ID vector in our workspace. We have not referenced the data frame. All right, so if we do 2 times ID, notice that this command just prints a value to the console. It doesn't create a new object in the workspace. We still have the same objects. So all we're doing is doing algebraic manipulations on objects and printing them to the console. We're not saving them as new objects. We could do that if we wanted to. So basically what 2 times ID does is just multiplies each element in ID by 2, by the scalar number 2. So if we do ID by ID, we'll see that what we're doing is an element by element mathematical operation where we're multiplying the first element of ID times itself, the second element of ID times itself, and showing that. So we're essentially squaring each element is the impact that that has. For C, by doing ID greater than 3, what we're doing is, this is asking R to look at each element of the vector and whether or not it's greater than 3, and returns the corresponding logical evaluation. So the question is the first element of ID greater than 3? Well, no, it's 1. Is the second element greater than 3? No. Is the third element greater than 3? No. It's not greater than, it's actually equal to, but this is a strictly greater than. So we only get trues for 4 and 5 being greater than 3. So this is a logic operation. Now let's look at this last bit where we're asked to run these 2 commands. So let's assign, let's look at what temp is doing here. So assign the sequence, the vector that is the sequence from 5 back to 1 by 1. So let's just do temp, and then I'm just going to type in the console temp, and we see it's 5, 4, 3, 2, 1. Now we can look at ID, which we know is 1, 2, 3, 4, 5. And now let's type ID equal temp and see what that does. So what this is doing is comparing each element in the corresponding vectors one by one to see if they're equal or not. So it's saying this is doing an element-wise comparison between ID and temp and returning the logical of whether or not they're equal. So of course we can look at this here. 1 is not equal to 5, 2 is not equal to 4, so we get false, false. The only element that's true is 3 is equal to 3 is the middle value. So it's false, false, true, false, false. Okay, question 3. All right, so this code below generates 1,500 random values stored as the object var x. So the seed value, if we don't set the seed, this is a command to tell R how we want it to generate the random values. By setting the seed to a specific number, we ensure that everybody gets the exact same vector of numbers. If you don't set the seed, it generally will set it to something associated with the current clock time, and so the seed will change depending on when you run this. So by setting the seed, we fix the vector that's going to be created. It's random for all of us, but it's the same random set of numbers. So then we're assigning to var x. This is the R norm, has to do with it's generating normal random variables, normal random numbers, 1,000 of them, with mean and standard deviation of 120, and 500 with mean of 200 and standard deviation of 10. So essentially we're generating 1,500 random numbers from 2 different normal distributions, and the reason we're doing that is just so it's an interesting picture. So let's look at what happens. The set seed doesn't print anything out. It just sets a seed. So if we say varx, we get this new vector, and if we look at it, it's just 1,500 random numbers from those two normal distributions. So let's bring up our workspace. We can see this is a numeric vector of length 1,500 that we've created here. All right, so now if we do hist varx, we will get a basic histogram. And I'm just doing the beginning of export here so we can see it a little better. So here's the first normal distribution, and here's the second normal distribution. So 1,000 of these, 500 of these. Notice that here we have generic. The X label is just the name of the objects. It's just histogram of varx and frequency. So now we're going to be asked to do a couple different things. The first thing is, if you want to look at the help for this command, this hist command, you type in question mark. Let's bring this up. And again, now we see here's the usage, and then within here we can see all the different options that are possible to use. And then in the arguments section, it goes through all the different arguments and talks about what they do. For example, breaks is one of a vector giving the breakpoints, a single number giving the number of cells for the histogram. So we're going to use that. That tells you how many bins you want to use. So there's a number of different things that can be done with breaks. And then further down, we're going to find main x lab y lab. So that's main x label y label is what those are for. And it says these arguments to title have useful defaults here. So title is the clue here that this has to do with labels for different parts of the histogram. Okay, so the first thing we're asked to do is to title the figure and label the x-axis. So we can do that by adding some arguments here to our basic hist varx. So we have a comma, and then we have main equals, so that's the main title on that's above the histogram, and in single quotes we simply put the title, and then a comma, then our next argument is xlab, and then again in single quotes we can put value of x units. Then we have to have an open and close paren on the actual syntax, the histogram function that we're using. And now if we run this, we will get, now we have the labels that we wanted. So let's scroll down a little bit here. Now we can simply add the breaks equal 20 to have 20 bins instead of the default number. So let's run that and see what that does. So we got more bins. That's a nicer looking histogram. And now we can shade using the COL option from the help menu. Let's see if we can find that. There's COL here. A color used to be filled the bars, and Megan had provided, you can usually type basic colors in there as titles. You can also go to the web page she provided and type in numbers, but if we do this, now we get a colored thing. Now one thing I want to point out about the way this command is entered into the script editor, notice that when the way Megan's done this, she has one option per row. This is just a nice way to structure your code so that it's easy to see what the different options are. If you look at the help menu, they just kind of stack it all up here a little bit. They have multiple ones per line. It's just a little bit easier to read what's going on, particularly if you have a lot of options that you're setting in your function to include them, and you can just end each line with a comma here, and then the final one you just have to have the closing paren. Okay. All right, so question 4. This one I'm not going to go through, but basically there's a number of ways you do this. The point of this one was just to get some experience with formulating search terms in Google is usually the best search engine to use, I have found, for R, and a number of ways. So, you know, my default would be to Google Draftsman's plots in R would be the first thing I would do, and then start scanning through. We've listed here a number of different packages that will allow you to do Draftsman's plots. Then it's just a matter of picking one and figuring out what the appropriate syntax is to get the figure you want and what the input is that you need. So for example, the pairs function here, the first one that's listed, there are no additional packages needed, but the input to this is a matrix or a data frame. So let's see if we can just put data 1 in there and hit return, and there we go. So there's our it's not the greatest looking thing, but that does demonstrate the Draftsman's plot. Okay, so now we finish this all up. We're assignment 1. So there's actually nothing to do. This is currently all saved in a project. One thing I will note is when the title of a script file in RStudio is red, that means that you've made changes to the file that have not been saved. And so if we go ahead and close, I'll just do this, it should ask us, it says there are unsaved changes, do you want to save the changes? So I save them, and now we close RStudio and we're done. That's all for this video. Thanks.